Alright, so in this problem, I have 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 512. So to solve this problem, I'm going to first start by factoring out 4 to the power of x. So now I have 4 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 512. Now I'm going to rewrite 1 plus 1 as 4. So now I have 4 to the power of x times 4 is equal to 512. Now I'm going to divide both sides by 4. So then these two cancel out, and now I get 4 to the power of x is equal to, actually, instead of doing that, I'm actually going to multiply these two. So if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 4 to the power of x times 4 to the power of 1, that's going to equal 4 to the power of x plus 1, which is equal to 512. So now I'm going to rewrite 512 as 2 to the power of 9. So I have 4 to the power of x plus 1 is equal to 2 to the power of 9. And 4 here, I can rewrite as 2 squared. So now I have 2 squared to the power of x plus 1 is equal to 2 to the power of 9. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x plus 1, that's going to equal 2 to the power of 2 times x plus 1, which is equal to 2 to the power of 9. Now if I distribute the 2, I get 2 to the power of 2x plus 2 is equal to 2 to the power of 9. And if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, m is 2x plus 2, and n is 9. So now I have 2x plus 2 is equal to 9. So to solve this, I can subtract 2 on both sides. These two cancel out. So I get x equals 7. And if I divide both sides by 2, I get x is equal to 7 over 2. So now to check, I have 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 512. So 4 to the power of 7 over 2, this is 4 to the power of 7, the square root of 4 to the power of 7. So if I plug in this to a calculator, I get that the square root of 4 to the power of 7 is 128. So I have 128 plus 128 plus 128 plus 128, which is equal to 512. So this is right. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x plus 5 to the power of x plus 5 to the power of x is equal to 1000. So to solve this, I'm going to first start by factoring out 5 to the power of x. So now I have 5 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 1000. Now 1 plus 1 plus 1 plus 1 is 4. So I have 5 to the power of x times 4 is equal to 1000. Now if I divide both sides by 4, these two cancel out, and I get 5 to the power of x is equal to 250. So now I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 250. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So now I have b times log a. So log 5 to the power of x, I can move x to the front. So now I have x times log 5 is equal to log of 250. Now if I divide both sides by log 5, these two cancel out, and I get x is equal to log of 250 over log of 5. Now, log of 250, I can rewrite that as log of 25 times 10. And if I have something in the form log a times b, this is going to equal log a plus log b. So log 25 times 10, that's going to equal log 25 plus log 10 over log 5. And this is equal to log 25 over log 5 plus log 10 over log 5. And log 25, that's log of 5 squared. So I have log of 5 squared, and remember I can move this exponent to the front, so this is the same thing as 2 log 5 over log 5 plus log 10, which is equal to 1 over log 5. So then these two cancel out, and now I get x is equal to 2 plus 1 over log 5. Alright, so in this problem, I have 3 to the power of x squared over 9 to the power of x is equal to 27. So I'm first going to start by rewriting 9 as 3 squared and 27 as 3 cubed. So now I have 3 to the power of x squared over 3 squared to the power of x is equal to 3 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of x, that's going to be equal to 3 to the power of 2 times x, which is 3 to the power of 2x. This is equal to 3 to the power of 3. And now I can rewrite this as 3 to the power of x squared times 3 to the power of negative 2x is equal to 3 to the power of 3. And a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So this is going to equal 3 to the power of x squared minus 2x is equal to 3 to the power of 3. Now, if I have something in the form a to the power of m equals a to the power of n, this means that m is equal to n. So in this case, x squared minus 2x is equal to 3. So now to solve this, I'm going to subtract 3 on both sides. So then these two cancel out. So now I have x squared minus 2x minus 3 is equal to 0. And now to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 2, and c is negative 3. So I have x is equal to negative of negative 2 plus or minus the square root of negative 2 squared minus 4 times a, which is 1, times c, which is negative 3. And I have this over 2a, so 2 times 1. So now this is equal to 2 plus or minus the square root of 4 plus 12 over 2, which is equal to 2 plus or minus the square root of 16 over 2, which is equal to 2 plus or minus 4 over 2. So now I have 2 plus 4 over 2 and 2 minus 4 over 2. So I'll get x is equal to 3 or negative 1. Alright, so in this video, I'm going to be solving the equation x to the power of x to the power of 3 is equal to 729. So, to solve this, what I'm first going to do is take the power of 3 on both sides. So I get x to the power of x to the power of 3 to the power of 3 is equal to 729 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. Now, m times n, I can also rewrite as n times m. And if something in the form a to the power of m to the power of n is equal to a to the power of m times n, then a to the power of n times m should also equal to a to the power of n to the power of n. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of n. So now from here, I have x to the power of x to the power of 3 to the power of 3, and I can think of x to the power of 3 as m and 3 as n. So if I switch the places of these two, I get x to the power of 3 to the power of x to the power of 3. And remember, this is equal to 729 to the power of 3. Now, from here, I'm going to let x to the power of 3 equal to the variable y. So I get y to the power of y is equal to 729 to the power of 3. Now, I can simplify 729 to the power of 3. So 729 is the same thing as, 729, let's find some factors of this. So a factor of 729, let's try to divide this by 3. 729 divided by 3, we have 2 over here, so we get 6. We subtract 7 with 6, we get 1. We bring that to 2. 3 times 4 is 12. And now we bring that to 9. 3 times 3 is 9. So I get 729 is equal to 243 times 3. Now, 243, if I divide this by 3, I get 81. So I have this times 3 times 81, or sorry, I have 3 times 3 times 81, and 81 is the same thing as 3 to the power of 4. So I have 3 times 3 times 3 to the power of 4, which is equal to 3 to the power of 6, meaning 729 is the same thing as 3 to the power of 6. And 3 to the power of 6, I can break that down into 3 squared times 3 squared times 3 squared, which is equal to 9 to the power of 3. So I'm going to replace 9 to the power of 3 with 729. So I get y to the power of y is equal to 9 to the power of 3 to the power of 3. And the reason I did this is because 9 to the power of 3 to the power of 3 is the same thing as 9 to the power of 3 times 3. And 3 times 3 is 9. So I get y to the power of y is equal to 9 to the power of 9. And now I can use the property a to the power of a is equal to, if a to the power of a is equal to b to the power of b, this means that a equals b. So in this case, y is equal to 9. Now, recall how I let x to the power of 3 equal to y. Meaning, I get x to the power of 3 is equal to 9. So now to solve this, I'm going to take the cube root on both sides. So I get the cube root of x to the power of 3 is equal to the cube root of 9. Now the cube root of x to the power of 3 is simply just x. So I get x is equal to the cube root of 9. And this is the same thing as 9 to the power of 1/3.